Okay, so let's see where we left off, and hopefully we can look at Cloud 9 today. All right, so we talked about hardware registers, talked about forking, we talked about alternatives to forking. So what's the difference between a process and a thread?
Thread is governed by the process that's loaded on CPU.
Okay, so a thread is completely so governed. Ultimately, means its CPU time is shared with the parent. So if a parent process spawns off 3 threads, now you have 4 threads. So the parent was a thread, and then 3 child threads. Those 4 are sharing the single amount of allotted time that that process was getting on the CPU, as opposed to fork, which does what? Creates a whole nother process, and that process gets its own total amount of CPU time. So in that particular case, you have you get more CPU time at the cost of using more system resources to store the process. And then from our perspective, though, in here, you may have seen this. Have any of you ever seen that acronym before? IPC? What does it stand for? Anybody know? You just seen it? So this is interprocess communication. Okay, now this is going to be a big part of what we deal with this semester. We might do some threading stuff, but typically when you're dealing with systems programming things, you are creating multiple processes that do different things. This is actually kind of related, we might say, to MVC, at least loosely. What's MVC again? Model view controller, and what does that basically say? So separate the logic from the interface and data, something along those lines. All right, so it's kind of loosely related to that, in that what we have here is when you have on a system, let's say we have 2 processes. Well, here, I actually want to draw a picture for this. It'll make a lot more sense. All right, so we have the OS that's governing all the crap that's happening, right? And the OS has a whole bunch of modules, process management, memory management, blah, blah, blah. But for this example, we can just kind of throw it up there as the governing operating system, okay? Then we have a couple of processes. And of course, processes are red. All right. Now, these processes, let's assume that this was the parent process and this was the child. So we'll make the child green. So these guys are related to each other, right? So this guy was the parent, spawned off the child process using the fork system call. So now these guys are floating out there on the operating system as independent processes. Now, we know that they're at the very least related to each other at the birds and the bees level, right? Now, that doesn't mean that they'll ever actually have to communicate with each other from that point forward, but we might say it's probably likely, right? If one process spawns 2 or 3 other processes, chances are it's dividing up its work, and at some point that stuff needs to kind of come back together. So, if we're taking some modern problems like video conversion, let's use that as an example. When we start getting into the real advantage of having a massively multi-core processor, if you're converting a 1 gigabyte video file with a single core processor, it'll take way, way longer than it will with a 4-core processor. Probably, well, let's call it 4 times longer. If everything else is the same, because the work of converting a video file can be divided up into multiple pieces. Well, at the end of the day, though, if you're going to have those 4 separate pieces working on the video, they're 25% of the video. At the end, they need to bring all that data back together, right? So somebody's going to have to be in charge. Maybe it's the parent. Probably it's the parent. And after the 4 children do their job, it's going to be all that data needs to be brought back to the center so that the parent can present it. Here's your MP4 that I converted for you, something like that. All right. So more than likely, when we have a parent process that spawns one or more child processes, it's going to be pretty common that these two need to talk moving forward, right? They don't just dump it out and let them move on with life. And, like, is that how turtle babies are born? Let the turtles come up and lay them in the sand and then just leave. That's it. Never to speak to mommy again. All right. So more than likely, that wouldn't be our case. Chances are if a parent spawned a child process, they're going to have to speak in the future. Now, the issue here is that when we're dealing with threads, if this was a parent process and this guy had, threads would obviously be circular, right? So maybe this is T1. And threads that's not pink. Is that, what is that? Is that violet? It's raspberry. It's magenta.
Magenta is more pink than that.
All right, so let's say we have a process that has 3 threads. These guys never actually left the house. It's like having the kids upstairs. You could just yell in the house and kind of reach them. You still have to have kind of almost a fakey type of inter-process communication, but it's a much more local problem, right? Where multiple processes, they're in different houses, maybe different cities, whatever. And now you have to think about what are the various communication channels that we have available to talking to the child. Phone call, text message, whatever it is. Make sense? You can't just yell. I guess if you could yell really loud, like insanely loud, you might be able to reach somebody that's like in the yard or something like that. But once they get a reasonable distance away, you're not talking to them anymore. All right, so if we kind of think about this from a historical point of view, as well as how a lot of systems programming ends up working, these 2 processes might live in different states or towns or streets or whatever, where we don't have convenient communication between them. So now we need to have a mechanism. So interprocess communication represents a mechanism for processes that live in the same operating system to talk to each other. Okay, and we have several different mechanisms for doing this, and we'll talk about those various mechanisms here. But we have something called shared memory. We have something called pipes. Lots of different things. Technically, you can use sockets, although it would be an overkill. We've talked about sockets. What's a socket? Go ahead. Okay. Yeah, and typically we think about it as over the network, right? So technically, if these guys didn't want to directly use the operating system to do their communication, this guy can open up a socket, and it was going to go out here on the internet, hit DNS service, blah, 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 connect back to the IP address of this guy. This guy could be listening on a different port on there, and you can actually connect a socket between these two where, even though they maybe live 2 houses down from each other, you've actually gone to space to make that communication. Not the most efficient way of doing it, but that could work. If you've only ever worked with sockets and you need 2 processes to talk to each other, technically they didn't have to be on the same machine, but if they are, that's okay. You can work with that. Okay, so this whole idea of inter-process communication is something that we're going to have to consider, especially as we start moving towards this idea of writing a web server. Because if we're going to say, okay, I'm listening for the incoming connection. As soon as I have incoming connection, I'm going to create a child process. That child process is going to go and work for somebody else. That child might need to communicate back to the parent, maybe letting them know that they're done. Last time we talked about maybe the difference between killing off processes when they're done versus kind of keeping a pool of processes. Maybe you decide that, the most number of simultaneous connections that I think my server can handle is 10. Let's just use that as an example. So we may be at the very beginning spawn off 10 child processes that are just waiting to be given work. And those guys sit there in a nice little pool. And when a new connection comes in, rather than the parent spawning a new child, the parent just goes to the pool and says, whoever's next in line, here's your customer. Go and work with them. And then when that person's done, they would, you know, maybe contact the parent again. The parent puts them back at the end of the line, that kind of thing. All right, so in any case, communication might need to happen. All right, questions about any of that stuff at the high level? All right, so let's look at Cloud9 a little bit and do some C stuff. I will hopefully be able to link your accounts to AWS Educate so that nobody gets billed for anything, but none of you, when you create your accounts, will put a credit card in, so don't worry about it. What we're going to set up will fall underneath their free tier. Just if you use it really, really heavily, in our case, probably by accident, like you create an infinite loop that uses too much data or something like that, you know, it might say you've run out of your free time on Cloud9. It probably won't be an issue, so you don't have to really worry about this. But once I get it linked to the AWS Educate, it will. I'll be able to put you under that umbrella, and then I think it just won't matter because they want you using this to learn as a tool and all that jazz. But what you'll do is you're going to go to AWS. I'm just going to do a. I think I have a link for it in. Actually, don't I have a link for it in here?
Mm-hmm.
Let's just use our link and make sure that guy works. Class says 450. All right, so this is Cloud9. I already have an account, so I'm going to just sign into my console. So if you don't already have an AWS account, sign up. Create one. Doesn't cost you anything. You don't have to put a credit card number off the bat anyways. Just don't put any credit card number, and then you don't need to worry about ever being charged for anything. At the end of the day, how many of you have heard of AWS before? All right, so this is Amazon Web Services. So if we just kind of throw this out here, we've heard of cloud computing. So cloud computing is kind of a global name that we use for saying processing stuff up in on somebody else's computer. We think of it as being on the cloud, but it's really just somebody else's machine on the internet. Okay, that is giving you some services that maybe are beneficial to you. So, for instance, cloud computing might encompass data storage. Maybe they have faster and bigger hard drives than you have, and they have some sort of mechanism for conveniently storing data and retrieving data and searching for data, blah, blah, blah. So it's a power tool for storing data so that you don't have to store it locally. All right. Then we have typically something called compute, which means they have more of and faster processors than you have, and you're doing something that is processor intensive. So rather than bogging down your computer to do something for a zillion hours, you use their compute engine where you're giving them the problem to work on their computers, and you're just paying for that processor time that you're getting from them. Make sense? All right, and then we can keep going down the list. Amazon, so AWS is Amazon Web Services. Now, when we talk about cloud computing, we have two different kinds of cloud computing. We have IaaS and we have PaaS. How many of you have seen those acronyms before? This falls into that category of, you know, 4 letters that we've seen next to each other but probably didn't have a clue what they meant. Anybody seen these before? All right. Do we know the difference? Anybody know anything about them? Okay, so all cloud computing platforms. So we have, you know, outside of AWS, we also have things like Microsoft Azure. We have Google App Engine, but now it actually has fallen underneath Google Web Services with like Firebase and things like that. But I'll just throw Google App Engine in here. All right, and there's some other ones out there, but let's call these the big 3. You know, Google, Microsoft, and Amazon. Pretty big companies, probably have a lot of computing resources, a lot more than you have, and you might be working on a project that would benefit from having their stuff so that you don't have to host your own servers and that kind of jazz. Okay, so now all cloud computing setups fall into one of these 2 categories. So this guy is infrastructure as a service, and this guy is platform as a service. All right, now here's the difference. So first of all, Amazon is an infrastructure as a service. So what an infrastructure as a service does is it effectively gives you what might seem like a virtual, so this gives you a, should say, hosted OS that you can install / configure however you want. And it scales with your needs. So what Amazon does is they effectively provide you with what to you looks like a Linux server. And then on top of that Linux server, you have access to all their other cloud computing APIs. But that server itself, you want to think of it as being kind of an elastic computer. So you can limit it to say, okay, I want it to be this powerful and I don't want to go beyond that because I don't want to pay for more than that. But you can say, okay, I want this computer to be the minimalistic footprint that it can possibly be because I don't want to pay if I don't have to. But then as your application becomes more and more successful and your needs become greater and greater, you want that machine to be able to instantaneously upgrade itself. More RAM, more processors, things like that, so it can handle more incoming connections, blah, 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 blah. All right, so what Amazon is doing is they're saying, here's a, let's just call it infinitely expandable computer. It's not infinitely, but you get what I'm saying. It's an expandable computer, but you have to set everything up on it that you want. Okay, but we're giving you the tool. We're giving you the infrastructure for you to do whatever you want. So this gives the end user total flexibility to solve whatever problem they want. One of Amazon's biggest clients is a little company called Netflix. So Netflix uses their infrastructure as a service and eventually, probably Netflix is already in the process of moving off into their own stuff. They're big enough now. But, the idea is that, do we suspect that Netflix is probably doing some pretty proprietary video compression-y type stuff? So it would make sense for them to want the infrastructure to handle all their data, but want to have complete control over how their implementation actually works, because it's a proprietary-ish type of thing. Where if they used something like a Google App Engine, which is a platform as a service, this guy essentially gives an API into the various resources. So everything happens, for instance, with App Engine, the way that Google decides it should happen. So if you want to stream video using Google App Engine is going to have one of their streaming resources, and you don't get to choose how your video is compressed or any of this other stuff. You're relying on them making good decisions, if you will. Now, for most applications, that's probably fine. In fact, for most applications, that might even be preferable. All right, where for something like Netflix, where they need to have full control over how their stuff actually compresses video and things like that, the infrastructure as a service gave them that flexibility when a platform as a service would not. So one is not necessarily better than the other. You might say in general, infrastructure as a service is more flexible, but harder to use because you have to do more of the work yourself. You're setting up the operating system. You're doing all the stuff, installing third-party things, blah, blah, blah. Platform as a service is less flexible, easier to use. So there's your trade-offs, right? So let's call it, I don't know, most of the time for people writing mobile apps or something like that that need some level of cloud computing, you're looking for a platform as a service. Because a platform as a service is going to let you just conveniently have your app talk directly to that, and you'll just let them do the magic behind the scenes of how everything should work. But every now and then, an infrastructure as a service might make sense if you're doing something kind of interesting. Now, where Amazon is also pretty popular outside of the whole infrastructure as a service thing is they have in their cloud computing, there's data storage. They have about, I think, 3 or 4 different data storage options, and one of them is called S3, and they're a secure storage server, I think is what it stands for, S3. That's been around for a while. That was kind of what got it all started. So if you need to store a lot of stuff like images and things like that in the cloud, pricing wise, Amazon pretty much has the market cornered. You can store a lot of terabytes for not a lot of money. But it's kind of cold storage. So this isn't something that you'd want to be retrieving data every 2 seconds. This is more of, hey, you want to store a 3 megabyte file, and then you want to store a whole bunch more of those. This is the cheapest way to do it. And then you can retrieve it, but it's not transactional. It's, you want to download an image, great, but you're not going to be updating a database every 2 seconds. All right. So that kind of gives you the broad overview of cloud computing in general. So an interesting thing here is if you go to Amazon Web Services and you look under services, look at all the crap they have. So if you want to talk about they're probably the king of cloud computing. You're going to have a service for everything. They got one for making peanut butter and jelly somewhere in here. They don't actually have that, but it wouldn't be all that shocking. So under compute, these are all things that are letting you do things with processors. Under storage, these are all things letting you store crap. Then you have transactional stuff. That's your database stuff. And a lot of these, keep in mind, a lot of these were not necessarily invented by Amazon. These are companies that Amazon acquired. So for instance, Cloud9, I've previously used that when it wasn't an Amazon thing. It was c9.io was the website. Amazon acquired them, and now it's one of their services. Notice they have a whole bunch of stuff in the machine learning space. This is going to be a big thing moving forward. Blah, blah, blah. Okay, so let me go back here. All right, so here's Cloud9. I'll go ahead and I'm just going to say get started with Cloud9. Maybe that takes me directly to the Cloud9 screen. Okay, so when you first go in there, you're going to see something like this, although you won't have this guy here. So can I actually just delete this? Whatever. I'm going to create a new environment. I'm going to pretend like I'm doing what you're going to be doing. So we're going to say we're going to create an environment here. And I'm going to call this guy CSC450 live, whatever. Okay, and then we click next step. All right, it's going to say, well, how do you want this environment to be created? Unless you know what you're doing, use the EC2 thing that will allow you to access it directly through a web browser. Otherwise, you could SSH into it if that's better for you, but do the EC2 thing. Then instance type. This allows you to pick how good the computer is under the hood. Choose the free one. There's one up at the top. This has 1 gig of RAM and it has 1 virtual CPU. I promise you we are not going to be doing massive stuff. So when we do something a little bit more complicated, it might be a little bit slow if we start trying to have 7 or 8 people connect to it at once. It'll be fine. All right, but it'll be free. All right, so choose that top one. Then you have your cost-saving thing. So if you when do you want this thing to go off? So this is the amount of time where it'll auto-hibernate your environment. This is only if you're not using it. So after you've stopped using your environment, it'll go to sleep after 30 minutes is the default. That's fine. Leave it as the default. The thing is that the longer you set this up, the longer you have it not go to sleep, the more time it's technically running, which is the more processing power that will go against your usage time, and eventually you might run out of free tier, where Amazon's going to say, oh, you can't use it anymore unless you pay us. Make sense? So 30 minutes default is good. What's the downside of this? Keep in mind, this is just when you're not using it. So after you're not using it for 30 minutes, it'll turn off effectively. So this keeps us from, for instance, we're talking about writing a web server in here, right? So as an in-class exercise or while you're working on your homework exercise, it'll still be running. You can then test it to see, I'm actually able to hit it with a web browser and it serves me some stupid little web page. And like, oh my gosh, I made my own web browser or my own web server. But after you've walked away for 30 minutes, your web server no longer works because it's going to go to sleep. So you're probably not going to be able to use this for creating the next competitor for Google's web server. It's not going to stay alive after you've walked away for 30 minutes. All right, we can all deal with that. Fine, okay. So choose the free one. Choose the after 30 minutes thing, blah, blah, blah. Don't worry about any of this crap down here. If you go to network settings, you can choose some other stuff for what the network virtual PC is and blah, blah, blah. So just leave it default. Click next step. All right, so they're saying, oh, here's the recommended best practices. So as usual, just don't read any of that and click on create environment. Because they actually want you to log in through something called their IAM protocol instead of having username and password. It's stupid, and it's stupid because I haven't used it enough to tell you how to use it. So it's so must be stupid. You know, I have a working knowledge of all things. Since I don't have a working knowledge of that, it's not a thing. So right now it's, I don't know, it's installing Linux. It's, you know, it's creating a little slice of one of their machines and giving you this little virtual machine space that's going to be running the Linux operating system on it. And so you'll have your own little Linux running here. If you really don't want to do this, or you have a Linux machine at home that you want to run the stuff, anything we're doing in here, you should be able to run in any flavor of Linux you might have at home. This will be more convenient, but if you already have Linux or you're dabbling with it and you at least want to do some of the stuff on there, the commands I'm showing you here will work in Linux. The only difference might be depending on which version of Linux you have. The package manager might be a different name. Like I think I'm pretty sure we use apt-get for Cloud9, and we'll find out here pretty quick. Okay, and here's our Cloud9 interface. So you got this nice little welcome tab. So as usual, just close that. Even though it did have a thing that said create file, that might have been interesting to us. But for the moment, I'm just going to drag this up here because this is our IDE up here. This is going to be where we can do our file editing and things like that. You know, file editing for normal humans, as opposed to the cool kids file editing where you might say vi test.c. And that's going to open up a nice text editor down here for us to do this without using, you know, modern day text editor. I mean, you want to feel like you're using this guy. So you can actually type stuff in here. When you want to write it, you hit escape, :WQ for write quit. And now you've created a new file. See your little directory up here? So that's the way everybody in here wants to do it. I actually would encourage you to learn VI, especially if you might be doing some hybrid IT stuff, because you being able to use a command line text editor at some point in your life might be Nano. Do you know where Nano came from? Let's go to the history. You threw it out there, this is on you. So there is another text editor called Nano, probably on here. So that's the one you've used as Nano? Okay, so that's weak sauce is what that is. Do you know where Nano came from? One of the early text-based email clients was an email client called Pine. And that email client, when you wrote a new email, it had a built-in web server called Pico. And then that's what people got used to when they used bulletin board systems. They got used to using the Pico text editor with the Pine email client. And so then when they couldn't figure out how to use VI or Emacs, one of the cool kid text editors, somebody ported that and made it just a text editor called Nano. So Nano today is the Pico portion of Pine. You should never use it because it'll give you a rash. Nano or Pico or any of that. Just don't use it.
I don't want to say it like we memorize the shortcut.
What do you mean memorize? You don't have to memorize. It just gets ingrained in your soul, dude. Most of you are probably going to come up here and you're probably going to say, I want to create a file, new file. And because, at the end of the day, we're weak, right? Especially you. And a little bit you. Right, so my challenge for you would be to learn VI. I think that would be a cool skill that, but most of you will probably just use the text editor built in here. All right. Oh, actually, I'll edit that in here in a few minutes. Okay. So let me just see what's already installed. Do I have GCC? Okay. Oh, it is previously installed. All right, so we're actually not going to have to install any third-party stuff here. So we have a couple of text editors, or I'm sorry, a couple of compilers available to us, as you see on here. Yeah. So some options for us. C compilers. So the old school default C compiler is called CC, which stands for C compiler. The one we're going to use, and actually either one would work fine for what we're doing, is called GCC. How many of you have seen that acronym before? GNU. You know what it stands for? It's not technically an acronym. I forgot what the name of this thing. GNU is not. Oh, go ahead. Do you know?
I could be remembering something else, but doesn't the G stand for GNU?
Yeah. Because the whole thing is GNU. It's not Unix. So GNU was really born with a Linux project. So what you have is that it was kind of in the where the idea of open source came from. So, for instance, the CC compiler is not an open source project. The GCC compiler is. So a lot of these older things would come from kind of our proprietary Unix. From our perspective, they'll both work. All right, but if you want to be part of the open source community and the cool kids and, you know, pretty much anything you're going to find online related to C is going to use GCC because that's what we've been using for 30 years now. So it's just a thing. All right, so and then the C++ version of this is something called G++. That's the I'm sorry. Yeah, G++. Okay, but we'll be looking at GCC for most of the time. So this is GNU, not Unix, is what that stands for. All right, so we'll go back in here. We're going to go ahead and we're going to create a file. So I'll go ahead. I'm just going to, if you wanted to create a new file, you can hit the little plus sign here, and that'll create a file in here. I'll just go ahead and double click on my file that I created. We'll use the weak person editor. Can I make this bigger that way? There we go. Is that big enough text? Can we read that? All right, so we're going to write our first C program. All right, so if I make some mistakes, I did them on purpose because I haven't written in C in a while. So in any case, pound sign includes standard IO.h is what this is. This is equivalent to import in Java. All right, and then we're going to have int main, int argc, char pointer argv, and then we'll do printf, hello world. Something like this. All right, so let's break this down a little bit. Now, what I'm going to do is I'm just going to put in a little multi-line comment down here so we can look at kind of the equivalent. Remember when you first learned programming, somebody says, probably me, that all programs begin and end with main? So if we were writing this guy in Java, what would we have? We'd have like, you know, public class test, and then inside there we'd have public static void main string array args system.out.println hello. Well, I'm going to claim that they're identical. Hello world. Just like that. Those two programs are the same program, written in two different languages. All right, the first one's written in C, the second one is written in Java. So now we want to look at the differences. We have to include something up here in C where we didn't have to include anything in Java. Now remember when I first started teaching you Java, one of the things I said is Java hides a lot of stuff from you. So Java, there's a little, there's kind of a hidden line here. Remember, anybody remember what line's up here? Go ahead.
Import Java.
Dot line, yeah. Import java.lang.star. So that guy is up there in Java programs, even though you don't see it. That brings in the core Java language. Okay? Now, because Java is kind of written in modules. So you have the core language, which is just your base, hey, this is Java. And then you have all these extra libraries that allow you to do things that may or may not be helpful. You have a math library. You have a util library, stuff like that. Things were even more broken apart in the early days of C. So the core C language only had primitive types built into it, among a few other things. So if you wanted to do any sort of input-output stuff, print crap to the screen or read stuff in from the user, you had to include the library that knew about those things. Make sense? All right, so now let's review one other thing here. Remind me, what's a compiler? Converts high level to low level, right? All right, so in the old days, we used to have what was called a single pass compiler. Now, in a single pass compiler, what you would have, forget about the standard I/O stuff. Let's say I wanted to write my own functions in here. So I had a function, let's just say int do something, takes no parameters, and returns a 4 for no good reason. All right. Then down here, I can call do something. What if I had that? In Java, we would say that doesn't matter, right? Java, as long as your methods are somewhere, or functions, whatever you want to call them, as long as they're defined somewhere inside the class, it's fine, no problem. With older C compilers, this would break. Well, it wouldn't break at this exact moment. It would break if I tried to call do something in there. It would yell at us because with a single pass compiler, it's going through here, it's going to see we're trying to call a function that it's never heard of because that function wasn't defined until later on. That make sense? So then the way to combat this in the early days was what was called prototyping. So you'd come up here and give like a little shadow version of your function up there. All right, little shadow version of your function up there. Then you could implement it down here if you want to have all your extra stuff kind of on the bottom. But up top here, you just had just enough information for the compiler to say, yeah, this guy's going to be a real deal. Here's his name, here's the parameters he takes, and this is what he returns. Make sense?
So it's almost like an interface.
Yeah, I think that's fair. All right, so in a single pass compiler, you either have to define your functions up top or you have to prototype them up top and then define them down here. Now, the prototyping thing at a certain level becomes non-optional because if you define functions in terms of other functions, you might have a chicken or the egg problem. So that's where you prototype all of them at the top so it's at least heard of it. Because you might have an issue down here where you have do something defined and then you have something else defined below it and maybe it calls do something, but maybe do something calls the function that you defined below it. And had you not prototyped it, it wouldn't have known about it. So you basically got into a situation where you pretty much always prototyped all your functions at the top. That way you had all of those things loaded into the compiler right off the bat. So when you ran into a function here that referenced another function that was written after it, it would work. Well, then what started happening is you started getting into the situation where your program started looking fairly cluttered because you had all these prototypes here at the top and then all your functions scattered throughout there wherever they were. But in a fairly big application, you might have just a pretty good list of prototypes up here, right? So what they started doing is they started moving prototypes into header files. So you would have a .c file, which is your logic file. Then you would have a .h file, and all that .h file was all your prototypes. So when you include it here at the top, it effectively embeds all those things in here. That make sense? So it was kind of a clean way of doing it. Then what was nice then is you can go and look at the header file. And the header file effectively gave you, kind of like you referenced, an interface. It would show you, here's all the stuff that this guy knows how to do. I'm not showing you the implementation, but it's all kind of the documentation, right? Especially if they put like a one-line comment in there or something like that on top of each prototype, describing what that function would do had you called it. You won't see the implementation in there, but you'll see the prototype itself. All right, so that's where that pound include thing comes from. All right, then we have, first of all, this function returns an int, where in Java, it returns nothing. I'm sorry, it returns nothing. Why do you think that in standard C, main returns an int? You could actually make main return a void now because GCC's been updated a bunch, but why do you think it returns an int?
Calls the system calls to like exit to that.
Okay, yeah, it's related to that. So the idea is that when you are writing system software, you're writing a program to run on Linux or something like that, it might be another program that calls your program. And it needs to know whether or not your program worked or not. So your program would have an output. Maybe 0 if everything went fine, maybe 1 if it didn't, or maybe you'd have 30 different outputs depending on how it didn't work. This is kind of early day exception handling. Make sense? All right, so that's why it used to return an int. Then in here, we have int argc and char pointer rv. Where in Java, we take in a string array. Only a string array. I'll tell you right now that what this guy is right there is a string array. That is a pointer, so you're pointing to the front of the array, and what lives in that array is a whole bunch of char pointers, the front of each of those strings. All right? We'll talk about that more, don't worry about this, just trust me right now, that's a string array. All right, we're good with that? That's a string array. Why do I need 2 parameters here where in Java I only needed 1 parameter? We're already starting off with the understanding that C is an older language than Java, right? Okay. We had a problem in C. Arrays didn't know how long they were. You didn't create an array, and then you couldn't create an array of size 30 and then ask it what's your length in C. If you wanted to keep track of its length, you needed a second variable to keep track of its length.
So that's array.length,
Well, yeah, this guy right here is the. So first of all, what's this whole? What are the parameters that come into main for? What's the purpose of that or this? I usually show it when I first teach Java. It's for command line arguments. So when you run a Java program, if you type in Java test cat, dog, elephant, and then you print out the contents of args, args will have cat, dog, and elephant in it. So it's if you want to pass in command line arguments to your program. Now the reality is in Java that's a pretty rare thing. But when you think back to well, for instance, somebody wrote the GCC program in C, and if I just type in GCC and press enter, it's going to check that string array, and it's going to see, oh, you didn't give me any input files. So if I say GCC blah.c, I'm giving it a command line argument. I'm saying the file I want you to open is called blah.c, and it's going to say no such file or directory. Make sense? Because it couldn't find that file because I didn't have one named that. So it was more common in C for you to be writing programs that run from the console and giving it inputs from the command line was a thing. Make sense? All right, so let me quickly go through the rest of this. So argc was the number of command line arguments, and this is where they're stored. Whereas args.length is the number of command line arguments. We only needed 1 parameter there. Printf is our old school version of system.out.print. We put a \n here to kick it down the line at the end. That's what println does on its own. And then we did a return 0 saying everything went fine at the end because main wants us to return an int. In C, it doesn't actually police this. That would be optional. So just real quickly, I'm going to go ahead and run this. So we're going to do gcc test.c. Seemingly nothing happened. I'm going to do a directory listing, ls. You're going to see a new file here called a.out. So /a.out prints out hello world. Make sense? All right, so for Monday, basically do what I just did. Get your Cloud9 account set up. Create a file that does hello world just like this. Run it. Show me that you can run it. Then take a screenshot of this whole thing and submit that screenshot, showing me that you have your environment set up and you can write a hello world program in C. So this screen right here is exactly what you're going to be submitting. Paint by number. Cool? All right, I'll see everybody on Monday.